So this is my home-built DIY 36-inch interior Pompeii pizza oven, wood burning. It's 48 inches on the outside. The dimensioning of it is from the Forno Bravo plans, but instead of being brick on the inside, it's stainless steel. So the floor is brick, and there's a half wall on the back that you'll see later on. But I built everything other than some of the obvious things like the dome that you see predominantly on the top, the stovepipe, that sort of thing. I've been looking at wanting to do a project like this for quite some time. So I've been looking at tank ends. These are, the one on the left is a brewer's kettle top. It's 12 gauge, 304 stainless steel. And the right one that you see there is the upper part of the dome. There's still sidewalls that have to go on it, but it's 10 gauge 316L stainless steel. I bought both of these off surplus, so I was able to get them at a much lower price than purchasing new from the manufacturer. This is kind of I would say, our inspiration of what, at least from colors and more of a modern Italian look to it with the red penny tile and the stainless steel. That's kind of where the inspiration that you can see in this oven there, where I got it from. There's a lot of designs. I'm not claiming that ours is fully original by any means. So this is the beginning process, and I'm a welder, I've done a lot of fabrication in stainless steel, so this is nothing too outside of what I'm used to doing prior to retiring. And I had some of these parts laser cut so that they would fit together really nice, and it's much easier to weld than cutting it out with a grinder or with a cutting wheel or a plasma cutter. So some of these parts that you're going to see in this thing are fairly precise parts, and it's much easier and actually more efficient and cheaper in the long run just to have them cut on a laser. You just get much better results. It's a little pricey, and so choose what you decide that you want laser cut if you go that direction. So all the welding that you see on here, although I'm not real happy with some of my welds, it's 100% penetration, so the weld goes all the way through, so it's basically solid, purge welded. I wanted to do that just so that I wouldn't have weak spots in it. It's all 10 gauge. The front hoop that you see here, predominant, comes straight out you. That's actually 12 gauge. All 316L for the interior dome. That lower ring that you see that is black, it's just a 36-inch angle ring, punched ring, and I did that so that while I was welding it's permanent in there. It's the only piece of carbon steel that is in this project, but it's protected from the weather, so there's no chance of it rusting or corroding or anything like that. I did that so that it would give me a much more stable platform that I could weld around. I'm not worried about it twisting, and it's just better that I can hold everything into place. And you'll see later on, I cut the top flange, the vertical flange, off of it before I bricked it. But you'll see that later on in the photos. So like I said, a lot of these parts, you see there's a few parts here that still have the vinyl laser film on it over the stainless steel. The stainless steel is just this portion of that you're starting to see now is 304. It's a number 4 finish, so about a 180 grit. So it's kind of like your appliances in your house, refrigerator, stainless steel refrigerator. That's the look of it. That's a number 4 finish. And this is where I'm just using blocks to get everything level and perfect. I leveled the table, so then I had a benchmark that I could do all my measurements and level and plumb and that sort of thing. That's very important in fabrication. So I clamp a lot of things together just to get an idea of how it's going to look. In this photo, I'm just starting to get an idea of how the smoke box on top of it's going to be laid out. And I'm laying this out, and this is just some relatively simple triangulation that I'm to get my curvatures of and my gores of almost like an elbow gore in a sense. It's the same layout technique, and it really helps to have some layout skills for doing some of this sort of thing. You can get away without it. You can do it out of square, but I wanted to do it round. It takes stresses way better in heating and cooling. So that's what I did. I found the flue and the smoke box to be probably one of the more challenging things in this project. Nothing you can't do, but there you go. So I like to repurpose as much as I can. So I found some stainless steel at a basically a stainless junkyard, and there's nothing wrong with it. It's 304 stainless steel 14 gauge, and it's got a polish on it, which isn't really necessary for what I'm going to use it for, because I'm going to use it for this. I'm basically doing my layout, and that's going to be interior, so you're not even going to see it. So this is looking underneath at where the smoke exits out and up into the smoke box. And again, I'm just got things kind of clamped together to make sure everything's going to fit properly before I start really getting into welding everything together. I do have some of the parts that are part of the initial part of the smoke box. It's 12 gauge that I rolled to that circumference. Now that I had my pattern built, I could just simply transfer that to the stainless steel and cut out the pieces with a cut wheel on a grinder. And it's all tied together, ready to go. And this is just a look looking kind of down from the top down through the smoke chamber. This is after it's all welded up. Totally unnecessary to grind and polish this out like I did, but it's just kind of in my blood to do that. So off to figuring out where my dome was going to set now that I have the height of where the flue and the smoke box comes out. I can kind of get an idea about where the dome is going to set in this project. And again, clamping everything into position, getting a good look at it, making sure everything's level and plumb before you start really starting to cut your other parts of the project. Now you notice you see a lot of green tape all over everything. Anything that's polished, if you look closely at where it's clamped, if I use like a vice grip or something, there's a piece of copper in between. Copper won't scratch stainless steel as long as there's no contaminants on it. That's a little tip. Or you can just use like what I've done here. I've used a plastic tip on my clamps. So normally when you make a base for a pizza oven, like a brick pizza oven, you would build your base and then you would pour a 4-inch slab of reinforced concrete. In my case, I wanted to keep this fairly light. You'll still see that it's somewhat of a heavy oven. So I used aluminum. This is basically, I guess it'd be considered a Z bar aluminum. It's 1/8 inch thick, 1 by 1 by 1. And I just had a bunch of this stuff, so I just welded it all together. So that's my platform that the insulation is going to sit on. I did go with 5 inches insulation to kind of keep that aluminum further away from the brick floor. So that's why I went with 5 inches of insulation. So this is that base that I'm talking about. You see some temporary wood blocks in there. And again, those are 5 inches tall. And so that, once the insulation is in there, obviously there's not going to be any wood blocks in there. And you can also see where I cut the vertical part of the steel ring off, but I left the lower flat on it. So I had to, when I put the bricks in, I had to trim the bottom of the bricks a little bit. In this case, I ended up starting to want to see what the penny tile was going to look like. I had some black penny tile left over from a job, so I just kind of stuck it up in there just to kind of get a visual idea. And you'll notice throughout this project, you'll see that I've got the penny tile in place just to see how it's looking. Now for the exterior of the oven, underneath the penny tile, I used 090 aluminum. and I wrapped the exterior with this 090 aluminum, 0.090 thickness. And again, I'm keeping things pretty light. I can still handle this stuff. I can still pick it up. I can still move it around. I can build everything in the garage, so I don't have to build it outside. This is a photo of it upside down. So I can easily get to the outside and I can weld everything in. Now I'm just getting started on the base. I'm at the point where I'm needing something to start actually building it off of. So my base is built out of 1 by 3 inch stainless steel tubing, 065 wall thickness, that I put a number 4 finish on, which is about a 180 grit, like I had mentioned before, and that's going to be the support for the oven. The uprights are 3 inch diameter round. You can kind of see a portion of one in the corner there. The cheapest way that I could find number 4 finish 3 inch 065 wall tubing was in sanitary spools. These are 36 inches long. They're primarily used in sanitary work, where you're pumping fluids through it or powders or whatever, but they have a trichlor fitting that would go on it. But these were one of the cheaper ways that you could get polished 3 inch tube. So this is where I'm just welding things together. This is actually everything upside down, so you're looking at from underneath of the oven now and getting everything lined up. You'll see a couple of, well, there's actually 4 aluminum 3 by 3 by 3/16 supports that are aluminum sort of welded to that aluminum structure underneath to give it a lot of rigidity. And then the 1 by 3 square tube, those are bolted to it. So again, getting an idea of how things are going to look, I clamped and taped the penny tile around it to get my true length. In other words, where the tile is actually going to come together. Clamping the stainless lower ring, which is covered in plastic right now, a laser film, and just getting an idea of what aesthetically it's going to look like is, for me, pretty valuable. It gives me ideas as I go along, and I'll have to make a lot of decisions at one time. Lots of clamps that I use in this. You can see inside there that the inner dome is actually supported by 4 1/2-inch all-thread stainless steel uprights that you can kind of see there. You can see one behind and beside the clamps. Again, you can see inside, you can kind of see some of the clamps inside of that. So the hearth that we wanted something kind of unique. So at least for us, this is a basalt step that I found at a landscaping supply area, and this is the actual side that you would normally stand on. Now they had a couple broken pieces, and you can see the one that's laying flat is actually the side that was saw cut, so it's much smoother. And then the side that's vertical, that's the actual side that we normally use for a step, because it would be a non-slip surface. So he sold me one of those for a pretty decent price. It was still like $150 for this piece. And I polished the side with a polishing machine, and then chipped the edge so we can get that kind of that rustic raw look. I'd never done it before, but we thought, well, hey, let's give it a go, and did that chiseled edge to it. And we really like how it turned out. Now this isn't quite the finished product. There's a couple of slits that I had to cut in it so it would slide into the oven. And you might be able to notice that in some of the photos down the road here. But right now this gives you an idea of what the hearth looked like. It took me the better part of a day to do this. So it was back to the flue again, and the smoke box, I guess you would call it. And that took a lot of time to actually get that, and a lot of that was just trimming and cutting and fitting and getting nice tight fits so I have a really nice weld that I can put it on. All of this that you see is welded is all TIG welded with a Everlast 185 AC/DC unit with a water cooling unit on it. So if you're a welder, you know what I'm talking about. So this is the insulation that we're using. It's the fiberboard, ceramic fiberboard that we used was a 2-inch piece and a 3-inch piece to give us our 5-inch. The rest of the insulation, it is 1-inch thick ceramic insulated blanket and multiple layers throughout it so that we could stagger all the seams in it. Throughout the project, or I should say throughout the dome, I put basically I wanted to monitor the temperature. So these thermistors go out throughout it. There's actually 10 in it. This is one of the few that actually penetrates the dome. This one goes directly in the top of the dome, and I can check in real time what the actual temperature is up there without using like an infrared or something like that. More of an experiment. This whole thing is like a hybrid oven, so I haven't really seen one out there like it. I'm not saying it's unique, but I just haven't seen one. So I was curious what the temperature were out throughout the exterior of the interior skin. So there's a bunch of them in there. And I think in the next photo, I start insulating everything. Everything is starting to get insulated. Everything's going together. What you see, that wire that you see up, that's one of the thermistors that I was talking about, so I can monitor the temperature. This is after, this is 4 layers of insulation, and the ceramic insulation, and just with the chicken wire over top of it to kind of hold everything into place. And it really did come in handy because setting this down in the outer skin was pretty tight. So this is the outer skin with it insulated, ready for the dome to be set into, and you can see the a couple of the 4 half-inch all thread pieces that this is going to go into. Now in this case, you can see I'm lowering it down, and I have a electric winch, cable winch that I use for which really came in handy in this project, so I could easily and lightly put it down into the interior of the oven. And you can see on the right side there's some wires from where all the thermistors come down through the bottom of the oven. And I just took my time and lowered it down in there. You can see, again, you can see the 4 posts sticking up where the angle iron ring will actually set on and then bolt it into place. So not a lot of room getting it down in there, and which is good. You know, I wanted to fill all the voids with insulation. This is when I started to realize that this thing's starting to weigh up. So I ended up building a post beside it. You can see on the left side the 2x6s I built. There's 6 of them there that are laminated together to take the weight. This is about the time I decided I would get a crane scale, a digital crane scale, to see how much this thing weighed. So this is a photo of one of the thermistors that checks the flue gas temperature as it comes out of the oven. A lot of that's curiosity, just to see what kind of temps I'm going to get into. Now this is before the rest of it's insulated. This has a minimum of 5 inches of insulation over top of the stainless that you see on the top where the smoke box is, and then there's areas in this that's upwards of 14 inches of ceramic insulation on top. So when this is actually burning now, the top is very close to ambient temperature, so pretty much outside temperature, even when it's running at 900 plus degrees on the interior. It doesn't get that warm. So this kind of gives you an idea what the hearth looks like in place, and on either side of the opening, that's where I had to make some slits in the basalt so it would slide in there nice and tight. So part of the thing about doing this was getting back inside of it. I'm a pretty small guy, fortunately. I can get inside and I can actually put the bricks in the back of it and build it on the way out. So, but I kind of had to get into my work here a little bit. And I still have the oven supported by the cable lift. And this is where I started weighing things out. And at this point in the process, I'm at 818 pounds. And that's with the stand and everything. That's pretty much everything that's constructed up to that point. So by this time we'd gotten our red penny tile, and we decided to do kind of a combination of red and black to kind of tie into a modern Italian look, at least in our eyes. And the black would go with the black basalt of the hearth and continue it around the oven. This is the wood basket that you'll see what I used for material for that. You see the curd with all the slatted stainless. Everything you see on the exterior of this is stainless. There's no aluminum exposed in the end. So we wanted to do a test fire, and you can see on the right side a bunch of wires hanging out on the side. That's where all the thermistors, and that's where I'm going to monitor the temperatures. So we fired it up, and I really wanted to see how hot that outside skin would be in the front, above, and around the smoke box. So we built a fire in it, and this fire is just at the beginning stages of firing up, and we ran it. We basically kept feeding it for the next 10 hours. We kept feeding it with fire, just trying to maintain temperatures of 900 to 1,000 degrees interior. And so we burned it all day, and just kind of checked the temperatures around, and kept an eye on the thermistors, and checked the outside temperature with an infrared on the aluminum for where the penny tile is going to go in. Of course, you might as well have a burger while you got a fire going, right? So this is some repurposed stainless steel I found 1x1. Stainless steel 065 wall thickness. And as you can see, there's kind of a theme of trying to repurpose as much as we want. It's still a very expensive project, but if I can repurpose, I will. And we had 3 of these, and I think it cost me $60. So this is the where I can kind of keep an eye on the temperature on it. You can see the monitor down here, and I could monitor that. A little bit of wood stack in there. You see the purpose of what we're doing. I believe the highest temperatures that we got to, and it was obviously around the door, was around 230 degrees, and that was with running the wood burner a little bit hotter than what we normally would. So I had made up basically a mock-up of the 090 aluminum with the penny tile on it. And the penny tile ended up being that the best thing that we could find that would hold the penny tile on there properly with the thickness that I had to work with was high temperature silicone. So 550 degree temperature rated silicone that stays flexible to around 425 is what we ended up using. So the temperatures that we were experiencing were well below that. Mostly to give an idea of the picture of a photo of the door that I built for it for when we're not really using it, and to hold the heat in to the pizza oven so we can bake it the next morning. So there's a little seal that you saw, the little black seal that went around the outside of it. Now what we did notice during our test fire was that the back of the oven, because that's where the fire ended up being in the back once you start cooking, it got up to around 225 on the exterior of the oven. So that aluminum 090 skin where the penny tile was going to attach was going to get pretty warm. So we decided we would put a half brick on edge on the interior of the oven, and that would give me a couple of things. It would give me a little bit more thermal mass, so I felt that would be good, and it also cut our temperatures down substantially on directly behind where the fire is in there. And you can see in here kind of how it's built. It comes around halfway around. It's about a halfway on the base, and that dropped our temperatures at the highest point. After burning it for 12 hours at high temperature, it kept our temperatures under 100 degrees on the exterior, which was great. So since we had a really nice fire going, we decided we'd make some pizza. Why not? And it's not quite done yet. We don't have the tile on the outside yet, but we built a nice fire, got it pretty nice and hot, and we cooked up some pizza, and it was very traditional dough, and it turned out great. That was the first pizza I ever made in it, and this is the paddle a buddy of mine gave me. And this is just laying out the penny tile, the permanent kind of penny tile, just getting an idea how it was going to look. This is after we cooked our first pizza. Again, I'm more a visual guy. I kind of want to know what it's going to look like when it's all done. So this is with the penny tile installed. Each individual penny tile has a little dab of high temperature silicone on it, and that's how all the tile is attached. Just a photo of it outside. Wanted to roll it outside to get a couple photos of it. As you can see, the temperature, we're up to 944 pounds. That's including the stand. Now this is with the black grout all installed. All around the outside is sealed with a high temperature RTV, and so the hearth is removable. The black basalt is removable. Underneath the basalt is basically, yeah, I guess I'd call it a kind of a rain tray, so that if any water would get underneath the basalt, it would just run back out. So it's almost like a pan in there. There's still spots it could get in, but this kind of prevents the vast majority of it getting in there. Now the next hurdle to get by was getting the oven to the backyard. So I ended up building a cart for it that was substantially wider. I had to roll it out on the casters that I built it on to get it out of the garage, and then jack it up and then put the wheels on, and to be able to get it into the backyard, which wasn't a long distance, but a couple of turns that we had to make to get through the gate. And the next photo here shows it as we come around the corner, and we just kept laying 3/4 inch OSB plywood that I'd ripped in half, and we just keep moving it forward as we rolled along. And there was a little bit of tree trimming that we had to do to get it back there, but it really only took us about an hour of very careful moving. And this is where its new home is, in the backyard on the patio, and it's just a matter of disassembling it, putting it on the casters, and lowering it gently down to the ground and leveling it. I have levelers on all the legs so I could get it level on the very out of level patio. The the chimney that I used on this is it's a double wall insulated chimney, 6-inch. I don't have a whole lot of photos of pizza yet. I'm a much better fabricator than I am a baker, but I'm coming along, and I've got a good tutor that's kind of bringing me along. He has a pizza oven also, so he's giving me some pretty simple dough recipes, and it really helped me out with what I need to do. But it's been a very enjoyable project, and we do a lot of things other than pizza in it. We cook chicken breasts in it, and we've cooked desserts in it, and rolls, I plan on getting into some bread baking, that sort of thing. But anyway, that's our pizza oven. I hope if you decide to build one, you go for it, because it's a super fun project.